Good evening and welcome to Mass Bay RRE's Third Thursday program for July 20th, 2023. For tonight's program, we're pleased to welcome Tom Laurenson of the Shore Line Trolley Museum in East Haven, Connecticut, who will bring us the story of Frank Sprague, father of electric traction. Tom is presenting remotely from his home in Connecticut. Tom, welcome to Mass Bay RRE.
Okay, thank you. We'll get started if we can. I hope that's what you're seeing, a welcome sign. Thank you for your interest in a gentleman that I find to be largely unknown, and I think he deserves to be a lot better known than he is. Here we go. We'll just open the curtain and reveal a certain amount of information about Frank Sprague. If you come down to Connecticut and visit the Shore Line Trolley Museum, you'll find our visitor center has his name writ large above the, at the top of the building. We think that's fitting, given his role in electric traction. And a shameless plug, you'll find out all about the Shore Line Trolley Museum at our website there. We are, as has been mentioned, partly in East Haven. The visitor centre is in East Haven, but 96% of our museum is in Branford, and indeed we are the Branford Electric Railway Association, doing business as the Shore Line Trolley Museum, a name that seems to tell people a wee bit more about what we are than Branford Electric Railway Association. So there's our visitor centre. Frank is acknowledged in 3 places on the front of the visitor centre, and he deserves to be so. There's the map showing where the Shore Line Trolley Museum is. The visitor centre is just there on the north side of that road, with a car park extending to the north of it, just up here. And the line takes us down here to the main part of the museum, including the workshop and a number of storage barns, and then it proceeds all the way down here to the short beach part of Branford. And this is a line that was built in 1900 and used by such luminaries as Mark Twain, who lived up in Hartford and took a train down to New Haven before taking the trolley through this area to get to the short beaches and hotels. Others include Greta Garbo. I'm not old enough to remember Greta Garbo, but I do remember her name. And this is Frank Sprague himself. It's impossible to find a photograph of this man with a smile on his face. I'm not sure why that is. Maybe he was just a serious person. Maybe the photographers of the day didn't encourage smiles because exposures tended to be fairly long in those days and you had to stay still. But there he is. He did have a temper, and we'll see perhaps where some of the colourful language which is attributed to him came from. So we'll look at his early life, at some of his engineering progress, and some of the key developments with which he was associated or which he basically invented. He was born in Milford, which is not far from where I'm sitting, just on the other side of New Haven. There's his house, and the bridge in front of us is the Jefferson Bridge and City Hall to the left. Both of these structures are still there, but Frank Sprague's house has vanished. I think the precise site is now occupied by a little grove of trees beside the Milford Recreation Department. He was born in 1857, but at an early age his mother died. His father couldn't cope with Frank and his brother, and so they were moved to live with relatives in North Adams, Massachusetts. They apparently moved around a number of relatives, but his aunt was the main person who looked after him and the person that he attributes his upbringing to. He went to school in North Adams, to the conventional public schools, but also to a military academy up there. And he did very well, particularly at mathematics and physics, and eventually was persuaded that he should sit the entrance exams for the US Army. He set off to do that for 4 days of tests and interviews, I suppose. And when he got there, he discovered that it wasn't the entrance exam for the US Army, but for the US Navy. He persevered. He went through with it anyway. There were 13 of them who did these exams, and he came out number 1. So he got into the US Navy. And he served on 3 ships, the USS Richmond, Minnesota, and Lancaster. All of these were essentially sailing ships with augmented by steam engines. It was only a few years later that the US Navy stopped insisting that all warships should have sails. So he was at a turning point in the Navy. And it was just as well that he went to join the Navy rather than the Army, because the training that he got with the US Navy in electrical engineering was far superior to anything that he could have got from the US Army at the time. With ships going over to steam power and electricity coming in, there was more scope for electrical engineering with the Navy than with the Army of the day. He had hardly joined the Navy when he was tempted over to Europe. He went to this first international exposition of electricity in Paris, and shortly after that went over to the Crystal Palace exhibition in London. Both of these were major exhibitions showcasing the latest in electrical developments, of which there were many at this time, because this was a new technology to the world, and all sorts of people were developing all sorts of things. He went on leave for a fairly short time and grossly overstayed his leave attending these exhibitions. So when he got back, you can imagine the first order of business was to report to his commanding officer and face the music, so to speak. But he arrived for that interview laden with brochures and leaflets and papers from these 2 major exhibitions, and the US Navy had no other representation there. So he brought back advances in electricity that the Navy was clearly going to benefit from, and so he he had no penalty for being absent without leave. But the Navy really wasn't for him, and in 1883 he left the Navy to join the Edison Corporation and work for Thomas Edison, which was a bit of a mistake in some ways because the 2 were completely different. This is the letter that he wrote about a year later when he resigned, and basically what he's saying is he is as keen to work on electrical motors as Edison was to work on electric lighting. Edison was not an engineer. He was not a mathematician. Frank Sprague was both of these things. In trying to develop electrical systems for streetlights for towns and cities, the Edison approach was to build a model, to take a huge warehouse and lay out wires along the pattern of the streets with little light bulbs representing the lampposts, and position a battery somewhere, and then have an assistant crawl around measuring all the voltages across the whole system, and then move the battery somewhere else and crawl around the system measuring the voltages to try and decide where would be the best position to put the power station. Frank Sprague looked at that somewhat appalled, pulled out a sheaf of paper, a pencil, and a slide rule, if anybody's old enough to remember what a slide rule was, and spent a morning doing calculations and said, there we are, there's the best place for the power station. This transformed the Edison approach to research and development. Edison had done much the same, trying to invent the light bulb, or at least trying to find the right filament, the right material for the filament for a light bulb. He tried everything under the sun. It would have not taken terribly much time to work out which would have been the best material had he been a scientist. Anyway, Sprague left the Edison Corporation, but didn't lose all contact with him because he was developing electrical motors and he had no manufacturing capability, but the Edison company did. So many of the motors that Frank Sprague developed were built by Edison. At the time, this was one of Edison's creations, an electrical generator, a dynamo, we would call it, and it was 1.6% efficient. Can you imagine just 1.6% efficient? For every kilowatt that you put in, you got out 16 watts or something. But the science was at an early stage. So Sprague turned his attention to electric motors. At the time, factories tended to have single source of power. the Industrial Revolution had started with water wheels, and when steam power came along, that replaced the water wheels, the steam engines being a bit more powerful. And that single source of power, that rotational energy, was transferred through shafts and pulleys to the various machines in the factory, which basically meant they all had to go at the same time. And if you needed to adjust the speed of your machine, there was really very little scope to do that. You might have a conical, pulley at your end, and you might be able to adjust it up or down slightly. But essentially, it was all or nothing. Everybody had to wait for the steam engine to fire up and spin, and then at the end of the day, the whole thing closed down. And it was dangerous. But Sprague went on to develop his motors and got this applause from Edison. Perhaps that was partly because by this time, Edison was an important customer to Sprague and making quite a bit of money out of his motors. But this is one of his motors. It doesn't look like much by today's standards. In fact, it looks pretty ungainly. But as we'll see, it was revolutionary in its day. The big thing is that these motors could be scattered about a factory and could provide power for individual machines, or perhaps for a set of 2 or 3 machines. And the power could be varied, and it could be switched off without switching off all the other machines. So the factory could work half the machines at a time without still having to fire up that huge steam engine. And this is one of Frank Sprague's earliest motors. We have it in our visitor centre down in the East Haven part of our campus, if you like. It has been switched on from time to time, and we do plan to switch it on again at some point in the not too distant future. Sprague was very meticulous in setting about the process of inventing and patenting things. And this is one page from his journal where he's drawn something, and you'll see down at the bottom right, he's signed it and he's had it witnessed. So it's dated, signed, witnessed. It's all there. And he did that with pretty well anything that he felt was a new development. Very protective of his rights, perhaps partly due to his experience with Edison, who certainly was very keen to make sure that he got the credit for anything and everything that might be happening. Sprague quickly put this newfound technology to work in trolley systems. Just before Frank Sprague was born in 1855, this is the kind of vehicle that went up and down the streets of New York, a horse-drawn, basically a stagecoach on railway lines. It even looks like an old-fashioned stagecoach from the Wild West movies, with the driver sitting up here on top. In the city of New York, I don't believe they needed the shotgun guy beside him, but you never know. And there was a little hatch just behind the operator where he could reach down and collect the money. Instead of the side doors that they had in the Wild West stagecoaches, the door is at the back. And this is the oldest vehicle in our collection. And well, we can move it around, but it's pretty frail. There were, at the time, other attempts to try and make electric trolley systems. This new technology was appealing, and people thought, well, if we can get rid of these horses, we get rid of a certain pollution that affects our cities. And so people were trying things. It's strange to see the Russians being among the first to try it. The one in Germany is interesting. We'll get back to that. The one in Blackpool in England is still there. At least the tramway is still there with modern equipment. It's a tourist attraction along the seafront. But the one in Germany is interesting. It looked like this, a fairly small vehicle, open-ended, and it drew power from its rails. You'll see there's nothing overhead. This sketch perhaps gives us a slightly better idea. This was like the train set that you had as a kid, a positive rail and a negative rail, and it ran on 400 volts. There is a controller here, a control mechanism here, and this is a handbrake, which was fairly typical of the time. Young teenagers, teenage boys in particular, being teenage boys, quickly learned with the system that a piece of wire, a short length of chain, a metal rod laid across the tracks would produce a nice array of sparks. And look at the woman there with her skirts trailing the ground. Women quickly learned that to walk across this in wet weather would give them more excitement than they could probably handle in that particular day. So this system, although it worked for a short time, it covered about a mile. Its length was about a mile, and it was pretty slow. It was pretty cumbersome. It didn't really survive. This is another vehicle of about that era. This is a locomotive with a motor designed by a gentleman called Van de Poel in 1888. You'll see it's a very low vehicle. It had to pass under a low bridge, and that's the reason for it. And it didn't carry passengers. It was a locomotive, pure and simple. It was built to pull freight cars between a factory and a dock area a few miles downstream. And this is the motor. This motor is the size of your dishwasher. It's about 35 horsepower, 26 kilowatts, and it has a chain drive. You'll see there's a gear arrangement. Oops. Let's just go back to that. There's a gear here for the high-speed motor going to this, and then down here we get this chain drive to the axle. The problem there is that as this thing bounced along the track, the chain would frequently come off the drive cog there, and that was a problem. It was difficult to get that back in place. What Frank Sprague did was to not only provide a small, powerful motor, far smaller than anything else that was around at the time, but to mount it in such a way that it would maintain contact with the axle. Perhaps best see it here. The motor, which sits here, is clamped via bearings onto the axle, and the drive is here. So as the axle goes up and down, so does the motor, and it maintains contact. This third wheel here is an early attempt at providing power. That didn't last either. So there are the motors. It's called a wheelbarrow method of mounting the motor. And he got a contract in 1887 to build a system for Richmond, Virginia. And this is the layout of the system. It went from one end down here to, well, two other ends up here, going through the center of Richmond. And one of the important things about this is the gradients. This is an exaggerated vertical scale, so it's nothing like as steep as that. But the point is it did go down into the valley and back up the other side. And this was also some 12 miles in length. The longest system up until that point had been little more than 1 mile. So Frank Sprague got this built, largely using Edison's manufacturing capabilities, and got it into service in 1888. And that, roughly, is the equivalent area in modern Richmond. You can see Churchill is still here. You'll see that in the next picture. Here's Churchill and the New Reservoir Park. So those were the two ends of the main part of his line. Up at the top, you can see the trolley wheel. And that's what gives trolleys their name, at least in this country. Elsewhere, they tend to be known as streetcars or trams. But that wheel, maintaining contact with the overhead power line, is what gives the trolley system its name. And this is a summer trolley. You'll see it's just a simple truck here. And at this end, we can see the speed control and the handbrake. It was an immediate success. And part of its success was that it was able to negotiate the slopes of Richmond. Here it is going downhill, we can tell, because the trolley pole is pointing to the back. And because everybody's facing that way, the operator's facing that way, and the conductor is facing downhill as well. And this is partly to show the slopes that the trolley negotiated, but also look at the quality of the road here. This is the flat bit, and up here is the uphill section of this bit of road. You'll see up here a distinctive part of a building that'll help you when we look backwards. But here's the trolley. Wouldn't that be much more comfortable than bumping your way across the streets in a hansom cab or something similar? And again, look at the quality of the road itself. It's bumpy, it's rough, and here are the rails, smooth, well, at least relatively smooth, comfortable. This was a revolution in transport that was astonishing to people of the day. They were used to railway lines, but railway lines tended to be on the outside of the town. They didn't tend to go right through the middle of town, and they were for long-range transport. But here, the lines are going right down Main Street, and you can get on at one end of Main Street and ride to the other end. This was a famous experiment that was carried out. Sprague was challenged by the city to show that there was enough power to keep the whole 40-odd vehicles going at one time. And so he had them lined up like this and set them off one by one to show that all of them could be powered successfully. The story is that the engineer in the powerhouse was told, there is the switch that, the safety switch that goes off if there's a problem. Your job is to make sure that switch stays connected regardless of what is happening. Perhaps Sprague wasn't quite as confident of his calculations as we might think. But there's the summer car in the fleet, and the rest of the cars, 40 or so, were of that enclosed design, but still with an open platform, the controller for speed there, and we can see the handbrake off to the side. I'll refer back to this picture because I suspect, I've got no evidence to back this up, but I suspect that this experiment helped to trigger a development that Frank Sprague made a few years later. It sounds about right, but I don't know for sure. Richmond is happy to celebrate Frank Sprague and acknowledge the quality of his system. 12 miles of track, 40 cars, and it ran until 1949. As far as I know, with pretty much the original vehicles. The thing that Frank Sprague was able to accomplish was provide a trolley system that coped with a bigger distance than anything until that point, that could go up hills that none of the other systems really tried, that was reliable because the whole community was relying on it to get to work, to get to the movies, to travel about the place, and it made money. Not necessarily a lot, but it was profitable. And within 2 years, some 200 cities across the planet in America, from Toronto to Rio de Janeiro to Buenos Aires, all over Europe, had developed systems using Frank Sprague's trolley technology. Boston was one of the first. It may have been the second city to adopt it, or maybe the third, but Boston was certainly well to the fore there. And the trolleys didn't just connect bits of the towns and cities, they began to connect adjacent towns and cities. And put yourself in the shoes of this poor man here. He's standing looking at a road that is in pitiful condition. It's wet, it's muddy, it's awkward. And he might have at one time been waiting for some kind of stagecoach to come along. And we've all seen enough Wild West movies to know that stagecoaches were not the most comfortable of vehicles to travel in. And suddenly the trolley company arrives, lays rails, puts up a power line, and this vehicle arrives to take him wherever he wants to go. It's comfortable. It's got better protection against the weather than any of the stagecoaches. It's cheap. It's a godsend to people of the area. So it's little wonder that people began to build houses out along the trolley lines. And the trolleys contributed significantly to urban sprawl in any city where they were developed. Many cities still have trolley systems. There's a whole list of them, and that's just a small number. And many cities are still building trolley lines. Seattle alone has built 2 new trolley lines in this century. People round about the New Haven area in Connecticut tend to think that trolleys are a thing of the past, but they certainly are not. And the Chinese are certainly building new and very innovative trolley systems, as we'll see later. At about the time that Frank Sprague was building his system in Richmond, auto transport was just coming online. Mercedes-Benz had brought out in 1886, just the year before Frank got the contract, had brought out this vehicle, and 2 years later modernized it, upgraded it, improved it, but still it's quite a contraption. And the US was a few years later, in 1893, by which time Frank Sprague's system was well in operation. Somebody took just a horse-drawn buggy, and stuck a little motor in the back here. The shafts where the horse would go, that's what would turn the front wheels. As the horse moved to the side, the shafts would move to the side and the wheels would turn. And that was replaced by this simple little rod. So you pushed it to one side or the other to steer. I'm not sure how he adjusted the speed, but I presume there's a foot pedal down there. And this is the splash guard to stop mud from the horse's hooves from covering you. And these vehicles did take to the streets, but look at the quality of the roadway that he's on. It's mud rutted, so it must have been pretty uncomfortable, even with these large wheels. So by comparison with this, what Frank Sprague was providing was smooth, was luxurious, was cheap, was innovative. No wonder cities fell over themselves to get these things. And Frank Sprague next turned his attention to elevators. He had the motors, he had the control technology, and he applied it to elevators. The elevators of the time were pretty primitive. This one was a rack climbing type. We can see the rack at top and bottom, and there's a mechanism here where a gear wheel fits into the rack and laboriously gets you there. There were pneumatic versions, hydraulic versions, all of them pretty slow and pretty cumbersome. And Frank Sprague came along with electric motors and with control technology that allowed him to safely stop the elevator at the different floors. And he developed a company he started a company to sell these things. And in a short space of time, in a couple of years, he sold 600 systems for buildings around the world. And the effect was immediate. In those 3 years, 600 elevator systems. They enabled this to be constructed, one of the first skyscrapers, if you like, of New York City. Back in Frank Sprague's day, 5 floors was about the limit for a building. If you think about it, 5, maybe 6 floors is about as much as you would want to climb, carrying the coal for your fireplace, carrying your groceries, carrying your children, carrying anything that you bought. 5 or 6 floors, that's about your limit. And in New York City in particular, 5, 6 floors was an additional limit imposed by the water system. New York's water came from the Adirondacks, and the reservoirs were relatively low down so that they could collect all the rain from the surrounding mountains. And so the height of the water there determined the water pressure in New York City. And there was enough pressure to get up to 5 or 6 floors. Beyond that, you would have to pump, you'd have to put in water towers. And in fact, for quite a while, the city apparently had an ordinance that limited buildings to the 5 or 6 floors. But with this new technology from Frank Sprague, as we've seen, the Park Row building could go up to 31 floors. And a bit later, we get the Empire State Building, which goes up to 102 floors. And now the tallest building in the world is 163 floors. And there is a problem the higher you go, and it's not just the amount of electricity you need to get there. Part of the problem is the higher the building, the more people are likely to be in it. And so the more elevator space and time you need. And that becomes a problem because that elevator space isn't revenue earning space, so to speak, the way an apartment or an office is. So there is a wee bit of a limit, and that's perhaps one reason why these buildings get slimmer and slimmer as you go higher up. Sprague sold his system to another company. We don't hear about Sprague elevators, but he sold his system to Otis, and Otis elevators pretty well cornered the market. The Otis contribution to elevators was the safety mechanism. If the wire rope breaks, a system kicks in to stop the lift compartment from plunging to the floor, despite what Hollywood movies might lead you to believe. Next, Frank Sprague turned his attention to something called multiple control. Here's the problem, again, down in New York City. We have an elevated railway line with a steam train. The steam train is passing right by somebody's bedroom window, making all that noise, emitting all that smoke and steam and sparks and all the rest of it. And steam trains were great, powerful beasts. They were good for pulling large trains, and they weren't very good at stopping and starting. They needed a long time to get going usually, and they needed a fair bit of time to get to a halt. So they were fine for long-range transport, but not for short-range transport. In the cities, we had trolley cars like this, and these ones, I think we can just make out there the trough in the street. These are pulled by cables, the way the San Francisco cable cars are. And they were kind of successful in a way. The cable slot was kind of vulnerable to the pollution, the emissions from the horses, and from mud being washed in by rain and all the rest of it. But cities had a problem, and New York City had a particular problem. This is Grand Central Station. It was called Station back in the days when it was open air, and steam trains came in and out. Looking north up Park Avenue, we've got a particular bit of the skyline there to help you orientate the view in another picture. The steam trains are going in and out, and that's fine, but to get there, they come down from Harlem and they go through a bit of a tunnel and emerge after that into the daylight. And there had been a problem. One train had gone into the tunnel and filled it with smoke and stopped. A second train came into the tunnel on the same line. The smoke obscured the view of the signals, and so it ran into the back of the first train, and there were a good number of deaths as a result of that. And the city decided enough is enough. No more steam trains through that tunnel, no more steam trains down into Grand Central Station. And so they embarked on this major project, there's that little bit of skyline again, looking up Park Avenue, to rebuild the whole thing. And they managed to do this and keep all the trains running in and out at the same time. And the writing was on the wall for steam trains, but they needed to be able to get electric trains in there. Now, there were electric locomotives, and that could be one solution, but Frank Sprague came up with something a lot better. Part of the financing for this whole project, by the way, was the idea that you could sell the space above the station. And the Waldorf Astoria, for example, is somewhere around here, above the tracks of Grand Central. And as we know, you walk down Park Avenue, this is Park Avenue, and there are huge buildings on either side with the station underneath. That's really what funded the whole operation, but Frank Sprague's invention made it possible. One of his inventions was this. You see this little thing down here? We saw a picture of that earlier on. Here's his invention. It's the little bracket that holds the third rail. The third rail is under there, and the train, as I'm sure you all know, have little wings, if you like, that flip out and catch under there and draw in the power from the rail. Frank Sprague's inventions still in use. This is where the line goes in underneath Park Avenue, just south of Harlem, the Harlem station. Frank went up to Schenectady in New York to try out his experiment. And I think that he thought back to that day in Richmond when he had to get all 40 of his vehicles running from the power station. And I think that when he thought about multiple control, he came up with a new idea. Other engineers thought you had to get all the power to the control cabin and feed it from there, control it from there and feed it out to the other cars. Frank Sprague realized that you didn't need to do that. What you needed to do was to send the signal to the other cars to increase and decrease power. In other words, you replaced all the operators in all the cars by a simple signal control. And he set up this experiment, and an observer wrote this about it. The cars were not physically connected. They weren't coupled together in any way. The only connection between them was the signal wire and a flexible air hose. And the cars ran and stayed together. 1897. The first place to take up multiple control commercially was Chicago. They were still working on New York at this point, but Chicago took it up. And basically, Frank Sprague's system is what all electric railways use to this day. Metro North use it, and there's Frank Sprague's little brackets holding up the third rail. So if you travel into New York City, you'll be doing so courtesy of Frank Sprague's developments. And so are these high-speed trains. The world has something, as I'm sure you'll know better than I, the world has something like 26,000 miles of high-speed train. Half of it is in China. There's a couple of lines in Japan. Most of the rest of the line is in Europe. There's one line in Morocco, and so far none in either North or South America. But these high-speed trains still basically work on the same system. The control cabinet, the control cabin here sends out control signals to the motors throughout. And I like to think that this also owes something to Frank Sprague. This is something that's been happening in the Netherlands, over in Europe. These are 3 trucks on their way to the docks in Rotterdam. The first truck has a driver. The second and third do not. They're simply following the control signals from the cab of the first truck. And they're going down the motorway, the freeway, if you like. And if this red car was to go into this gap between the second and third trucks, the third truck would fall back to allow a reasonable space between the 3 vehicles. If the red car pulled out back into this lane, this truck would close up. If they get to a red light and this one gets through just before it changes, these 2 will stop and wait for the green and then continue on the route as set by this truck. And so the 3 are likely to arrive at the docks, ready to be unloaded in pretty close order. And that's been going for 7 years now. And over in China, they've got a new development in modern trams that I think Frank Sprague would approve of. And again, there's actually more of a connection to this than you might think. This one runs on rails, but other versions run on the streets on rubber tires. And you'll see there's no overhead power line here. This one runs on batteries in the roof. And the Chinese have a successful one that's been going for 4 years now that uses supercapacitor batteries. And these are batteries that aren't chemical batteries like your car battery. Car batteries, as you know, don't do too well in very cold weather, but supercapacitor batteries can cope with cold weather. Your car battery, on the other hand, you can take out, charge it up and put it on the shelf for 6 months and take it off and it'll be pretty much as you charged it. It'll hold its charge. Supercapacitor batteries don't, but they don't need to. They just need to hold enough charge to get them where they're going. And the Chinese tram can reach up at each stop and recharge or refresh the charge since the last time it's recharged at the previous stop. The stops are about 700 meters apart, maybe a kilometer at the most. And the batteries have enough capacity for 5 or 6 stops. So even if 1 or 2 stops don't work, it still has enough to get there. And it recharges in 20 seconds, or at least it tops up in 20 seconds. It takes a little more than that to charge it up at the start of the day, but that's all automated. I think Frank Sprague would like that because of something else that's just about to come up. Here's a summary of the life of Frank Sprague, joining the Navy, working with Edison, and really transforming Edison's approach to research and development by introducing maths and electrical theory and engineering theory to Edison instead of the suck it and see approach for which he was notorious. Developing the first really efficient, compact, powerful electric motor, the Richmond contract that really spread trolley technology around the world, the elevator company that he started and sold to Edison, the pioneering of multiple control, principally in order to get electric trains into Grand Central, which, as you know, is now renamed Grand Central Terminal. And in his life, he won a number of awards. Remember, as a US Navy, I think he was still a midshipman at the time, he went off to Europe to the International Exposition of Electricity in 1881. 8 years later, he's winning a gold medal from that same exposition and winning other awards in his lifetime. So Frank Sprague was, to my mind, a brilliant engineer and mathematician, a man who made significant developments to the world of technology, but of electrical traction in particular. He well deserves the title, the father of electric traction, and he deserves a bit more credit than I think he gets. We acknowledge his contribution simply by having his name in front of it, in front of the public at our visitor centre. Another shameless plug, that's where to find out about us. And there's a little tale to this story, a little postscript to the story. The first is the postscript. I like the idea that Frank Sprague was inspired by his Richmond experience of starting up all his trolleys. I like the idea that that inspired him to invent or develop multiple control units. But one of his sons, Robert, went on to develop the Sprague electronic capacitor business. These are electronic capacitors. Most of these small ones are the kind of things you find in your radio. These bigger ones you might have found in an old-fashioned TV. And these ones are the kinds that you find in power supplies. These are the kinds that hold a charge, and that's why you never open up electronics, certainly old electronics, and poke about until you've given it some time for this to lose its charge. And those capacitors were made in Massachusetts, in these buildings here, which did have an industrial history. They had been used by other industries before, but in 1943, the Sprague capacitor business set up in these buildings. And these buildings, Massachusetts, which, if you remember, is where Frank Sprague went to school. And the buildings are now MassMoCA, the Massachusetts Museum of Contemporary Art. And I find that a nice little full circle story with which to end the story of Frank Sprague. And I would be happy to entertain any questions you might have, and I might even be able to answer one or two. You never know.